Alright guys, so here's our new video, or the next video. Let's see here, can you guys see everything okay? I'm gonna make these decimal points just a little bolder so you guys can see them. So, essentially though, what we're looking at is we're looking at the relationship between a exponential function here and a log function. So, taking these two functions in mind, they are related, they are correlated, I guess would be a nicer term to say. But what the idea is we are going to try and find what A equals, which is this guy right here. Try to find what A equals, what B equals, what C equals, and what D equals. So let's go ahead and put those over here, and those will be kind of our check marks as we go about. B is equal to, C is equal to, and finally D is equal to. Okay, well, let's see what we can do. So starting off, let's take a look at our first input right here. So we have log base b of y. When y equals a, we get 0. So log base b of y equals a. Again, rewritten our exponential form of this log equation is b to the a power is equal to y. Okay, well, let's take a look at this. This isn't necessarily helping us out too much, but we do know that this entire function here of a, or equaling a, uh-oh, I'm so sorry. Ay, ay, ay. Someone's got to stop me here. So, pardon this right here. Log base b of a. I was wondering why this is a little interesting. There we go. So, log base b of a is equal to 0, where, in this case, we are plugging our a value to where our y variable is. Our y variable being log base b of y, plug in an a for y, and we get our output, which is 0. So, we're taking a look at b to the what power equals a. In this case, the power that we're looking at is 0. So b to the 0 power equals a. Well, we know that anything to the 0 power is just equal to 1. So literally any number, if we have 2 to the 0 power, 3 to the 0 power, I don't want to make this statement too boldly, but infinity to the 0 power, they're all equal to 1. So for a term, a we now know to equal 1. All right, we're getting somewhere. Cool. What this also means is let's take a look at our next let's take a look at our next portion in our table here. So taking a look at this guy here, we're not really able to get too much information just yet. So let's focus on this table here with our variables and see what we can get. So log base b of y, so log base b of y, in this case when y equals 2. So log base b of 2, we get 1, which means b to the first power equals 2. Well, b to the first power, that just means b itself. We know b is equal to 2. Okay, sweet. So b is equal to 2. Getting somewhere here. Making some progress, getting some ground. And that kind of does make a little bit of sense to when we look at this. If b equals 2, 2 to the 1.585 power equals 3. 2 to the 2.322 power equals 5. Yeah, there's some weird numbers, there's some weird decimals in there, but don't let them intimidate you. They're just numbers, you know. Alrighty, so finally, let's go on to our next one here. We have log base b of 2c equals 1.585. So let's take a look. So we have log base b of y equaling 2c equals 1.585. So b to the 1.585 power equals 2c. Huh. Well, we know b is equal to 2, and 2 to the 1.585 power. I think we've seen this before. I think it's right. Boom, right there. That was a little tricky, actually. It's like reflective. Anyway, 2 to the 1.585 power. Hey, that's just equal to 3. All right, so now we have 3 is equal to 2c. Let's divide these guys out. C is equal to, sorry, my handwriting is a little bit off there. I got too excited. C is equal to 3 halves. We're over the hump. We're almost there. All we have is one variable left. I don't know about you guys, but I'm pretty excited. All right, let's get this last one knocked down and call it a day. So we have log base b of y, which is in this case 10d when y equals 10d. So the log base b of 10d equals 2.32 and 2. Well, we have b to the 2.322 power. So base b to the 2.322 power equals 10d. I ain't even stressing about this no more, because you know what? We know what b to the 2.322 power is. We'll look at our table right here. B to the 2.322 power is equal to 5, which means 5 is equivalent to 10d. Divide both sides by 10 here, and we get d is equal to 5/10. Simplified down, 1/2. 1/2. Box it, check it, square it. We're done, y'all. We got it. We out. Solved all of our variables right here just by knowing the relationship between logs and exponents, and kind of how taking one table, knowing that these guys here is an exponential function, this guy here is a log function. The biggest thing with these two functions here is that when we are looking at an exponential function and a log function, we need to make sure that our bases are the same. Log base b equals x, in this case would be y. We need to make sure that these guys here are the same. Using those here, or using these as the same, we're able to build a relationship, build a correlation, build all the little Asians. We'll be good to go.